Okay, so this first question here is a simultaneous equation, obviously because it says solve simultaneous equations, where we have one linear equation and we have one quadratic equation. So I'm just labeling those so we know what we're talking about. Okay, when we have a quadratic equation such as this in our simultaneous equations, we're going to try rewrite our linear one so that we get one letter in terms of another, and then we can sub that letter into this. So in this case, I think x would probably be easier to make the subject of the formula. So you have x plus 3y is equal to minus 5, so we want to get x on its own equals some amount of y's, so that's minus 3y minus 5. So now I've got x in terms of y. I'm going to use my second equation and I'm going to sub in my new value for x, which is minus 3y minus 5, into this. So I'll get minus 3y minus 5 now to be squared, plus y squared is equal to 41. So then I'm just going to multiply that out. That might take a minute, but we'll get 18y squared plus 60y plus 50 plus y squared is equal to 41. I know this is going to turn into a quadratic, so I want to move everything to one side and kind of tidy it up. So we have 60y, we have a 19y squared because we have this plus 1y squared over here, and we're going to minus the 41 on both sides, so we'll get plus 9 equals 0. Now I don't like the look of factorizing that, so I'm just going to use my minus b formula. So that's minus b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 19, b is equal to 60, and c is equal to 9. If I fill that in there, minus 60 plus or minus the square root of 60 to be squared minus 4 times by 19 times by 9 all over 2 times 19. And if I put that on my calculator, I'll get two values. I'll get y is equal to minus 3 or y is equal to minus 3 over 19. However, in the question, it said x and y are elements of z. Z means integers, if we remember, which is a positive or negative whole number. This is not a whole number, so that can't be our answer. So we're just going to eliminate that. So y is equal to minus 3, but we still need to find a value for x. So we know that x up here, from here, we know x is equal to minus 3y minus 5. So if y is equal to minus 3, x is equal to minus 3 times by minus 3 minus 5, which will get me, a 4. So that is our final answer. X is equal to 4 and y is equal to minus 3. And you would only lose 1 mark out of the 10 marks you get for this question if you did not exclude y is equal to minus 3 over 19. But that's just why if we're trying to get the 100% in a question, we always check kind of what form they want us to give the answer in. So they're always trying to catch you out in small ways like that in the leaving cert. Okay, the second simultaneous equation kind of yuki that we have, or kind of situation that you would have, is you have 3 separate equations for 3 separate letters. So in this case we have x, y and w. So same as normal kind of what are they called, simultaneous equations. We just want to get rid of, or we want 2 equations that have the same letter, but in this case they've asked it quite weirdly. So in every single one of these we have 2 letters, so we need to either, make one of these have only one. So maybe we could write y in terms of x, or that wouldn't work, we don't have y and x in any other ones. We could write x and y both in terms of w and sub that in here. So these ones, they seem to be asking a bit differently now, but we are just going to go on. So I'm going to label these 1, 2, and 3. So part 1, equation 1 I'm going to leave alone for the sec. For the other one, so for 2, I have y plus 3w is equal to minus 74. I want to write this so that I have y equals some amount of w's. So I'm going to move this 3w to the other side. So y is equal to minus 3w minus 74. Now I have y in terms of w. In my third equation, I want to now write x in terms of w. So I'll do that again. So I have 4x is equal to minus 5w plus 4, divide by 4, so x is equal to minus 5 over 4w plus 1. So now I have x and y both in terms of w. So I'm now going to sub these two that I've just made. I'm going to call these 4 and 5. So we're going to sub 4 and 5 into 1. So now we only have w's in that. So we have x, so x is equal to minus 5w over 4 plus 1, plus 2 times y, we know y is minus 3w minus 74, equals 143. And now we'll kind of rearrange this and try and make this make sense. So minus, we'll do the bracket out, 5w over 4 plus 1 minus 6w minus 74 times 2. We have 148 equals 143. So we want to get all our numbers on one side, all our letters on the other. So minus 5 over 4 minus a 6 is going to get me minus 29w over 4 is equal to, 143 plus 148 minus 1, which is 290. Then we're going to do is we're going to divide by minus 29 over 4 on both sides to get w on its own. W is equal to, 1 second, minus 40. So now we have got one of our letters. Now we want to try and get another one. So I know what w is now, and I know what y and I know what x is in terms of w. So I'm going to sub in my w equals minus 40 into both of these. So y is equal to minus 3 times by minus 40 minus 74. Put that in my calculator. Minus 3 times minus 40 minus 74 will get me 46. So now I've got my y. And then lastly, x is equal to minus 5 times by minus 40 divided by 4 plus 1, which equals, what's that? Minus 5 minus 40 over 4, which is 50. Okay, so this question we can do two ways. We can either use our long division method, which I personally don't like doing, or we can do what's called an identity, which is what we're going to do today, because personally I think they're easier. So we're told that 2x minus 1 is a factor of 2x cubed plus x squared plus kx plus 6. So that means that 2x minus 1 times something is going to get me this. So we have a bit of a trick in order to figure out what it needs to be multiplied by. So this is linear, and this is here is a cubic, this one here. This is a cubic, and we have a linear, which means that what we need to multiply this by is a quadratic. So quadratic, we know x squared, x, and some number, quadratic. So a handy little trick we know, the first thing here is going to get me my first term here. So 2x times by what is going to get me 2x cubed. And that's going to be x squared. We also know the last thing times the last thing will get me the last thing. So minus 1 times what will get me 6, that will be a minus 6. And then I don't know what letter or what number is in the middle, so I'm just going to call it P. Then I know that this side has to equal this side, so I'm going to multiply this side out, hopefully get something that I can use. So we'll get 2x cubed plus 2px squared minus 12x minus x squared minus px plus 6 is equal to this thing. I just don't want to write it out again. If I simplify that a bit, I will find out that I have something that looks like this. So I'm taking my x squareds, minus 1 here, and plus 2p there, and I'm just kind of writing that like that. And then I'm going to do the same thing with my x's. You don't have to do this. This is just what I prefer to do personally. And yeah, so we have minus 12x's minus p. So that still equals our cubic from above. I know that x squared equals x squared because this x squared, or this x stands for the same number as this x does, and x squared is equal to x squared. Therefore, the thing in front of my x squared is going to equal the thing in front of my x squared on the other side, which in this case is just a 1. So I know 2p minus 1 is equal to 1. So if I rearrange that, I'll find out that p is equal to 1. So I'm just moving my 1 to the other side, dividing by 2. That might be helpful now for my next bit. I'm saying x is equal to x. So therefore, what equals x on one side, so minus 12 minus p, is equal to k, which is on the other side. I now know that p is 1, so I can fill that in, is equal to k, so therefore k is equal to minus 13. Perfect. I have found out what k is. Now, the next thing we're asked in this question is to find the 3 roots of 2x cubed plus x squared plus kx plus 6 equals 0. I now know that k is equal to minus 13, so I can fill that in. So I have 2x cubed plus x squared minus 13x plus 6 equals 0. But even better than that, I know the 2 factors, and I need my factors before I can find my roots. So I know my factors are 2x minus 1 and x squared plus px, but I found out that p is just equal to 1. So plus x minus 6 is equal to 0. Now I need to split this again further into 2 factors. So that will be x, what's that, minus 2 and x plus 3 will get me that. And I'm just using my guide number method for that. And then I'll know that either 2x minus 1 is equal to 0, x minus 2 is equal to 0, or x plus 3 is equal to 0. And these are going to form my 3 roots. So I'll have x is equal to a half, there's 1 root, x is equal to 2, there's another root, and x is equal to minus 3, there's my 3rd root. And that's how I find my 3 roots. Now we have another cubics question. So the first thing we're told basically that shed type f can be modeled by this function here, and where x is the number of sheds sold and fx is the profit in euro. Fill in the table below showing that the value of fx for each of the given values for x. 2 of them are already given. Basically what that means is wherever we see x now, we need to put 0 in the function. So for example, for 0, we're going to have 400 times 0 minus 5 times 0 to be squared minus 0.4 times 0 to be cubed minus 900. And we put that in our calculator and we'll get values for every single one of these. That's how we do this question. And if we were to do that, we get minus 900, 2,200, 2,625, and then minus 275. Then we're asked to draw a graph for the function fx on the axis below for x's between 0 and 25. So for 0, we know that we're going to start around minus 900, so I'm just going to write a dot there. Then for 5, we're up at 925. Again, this doesn't have to be the most accurate in the world. 10, 2,200, it's around there. 15, 2,000 is here. So around somewhere there, I'd say. Then we have 20, we're now at 1,900. So somewhere along there, and then we're back down to minus 275. So around there. And then we're just asked to kind of draw a line. You'll draw one more accurately than me, but looks something like that. Then the next part of this says the profit from shed type G can be modeled by a different function, where x is the number of sheds sold and gx is the profit in euro. Show that x minus 16 is a root of gx. So how do we prove that? We literally just sub minus 16 into this function here and see if it works. Basically, does one side equal the other? Well, in this case, does one side equal 0? So g minus 16 is equal to minus 2 times minus 16 to be cubed, plus 55 times minus 16 to be squared, plus 974 times minus 16 minus 6,688. And we're seeing if that equals 0, because if it is on the x-axis, we know that y is going to equal 0, and x minus 16 is going to be one of our values. And if we put that in the calculator, we'll find that 0 does in fact equal 0. Happy days. We have shown that it is a root. Then hence or otherwise show that the other two values, or find the other two values for x element of R for which gx equals 0. So we know that minus 16 is a root, so therefore x plus 16 is a factor. So x plus 16 times by some quadratic, as we said before, is going to equal minus 2x cubed plus 55x squared plus 974x minus 6,688. So as we said, first times first will give me first. So x times what will get me minus 2x cubed. That will be minus 2x squared. And then last by last will give me last. So I'm going to use my calculator there. Say minus 6,688 divided by 16. It's going to get you minus 418. And then we don't know what the number in the middle is, so I'm just going to call it p. Then I'm going to multiply this out. I'll get minus 2x cubed plus px squared minus 418x. What's 16 times 2? Minus 32 x squared plus 16 px minus 6,688. And that equals the same cubic as above. We know that x squared has to be equal to x squared since x is the same number. So therefore, whatever x squared equals on this side, which is p minus 32, is going to equal what x squared is equal to on this side, which is a 55. So therefore, p is equal to 87. Plus 16 times by this quadratic that we just found here is going to equal 0. So now I have to split up this quadratic into two linear factors. And I think I'm going to use the minus b formula to do that, because I don't want to have to do that using the guide number method. Of course, you're more than welcome to. I just personally would not like to. So if we do the minus b method, you will get what's it? So this one is going to turn into x is equal to minus 16, which we already know, and this will turn into x is equal to 11 over 2, or x is equal to 38. So there are our three factors of that cubic there. The last part of this question says the profit from shed type H can be modeled by another function, hx, where x is the number of sheds sold and hx is the profit in euro. The diagram below shows the graph y is equal to hx, where sum of x equals r. Sorry, x is an element of r, r being our real numbers. The coordinates of 4 points on the graph are given below. That means we need to use all 4 of these points. We want to write hx in the form a times x minus b, x minus c, and x minus d. So, this one, not awful to do. So, if we take this kind of in two parts, I'm going to take these x parts and this a part as another kind of thing. So, to find my a, what I need to do is I need to times all of these three numbers that make up my x coordinates together. So 21 times by minus 12 times by 47. I'm going to do that. That will get me, what's that? Oh, sorry, I wrote that the wrong way. That will be a minus 47 because if we write them as roots, we will get x plus 21, x minus 12, and x minus 47. And the reason we'll get that is because if x is equal to minus 21, we want to get it on the same side. So to get this over to the other side, we'll have to add 21. So x plus 21 is going to equal to 0, and that's what all of these things do. These all have to equal to 0. Anyway, that's where we get our numbers from. I'm going to divide that whole thing by... Sorry, we're not going to divide that. We're going to multiply them all out. That will get me this. Then I'm going to take my y-intercept, minus 1316, divide that by my 11,844. That will get me minus 1/9. So now that's gotten me my a. I've gotten my 3 kind of x parts. So I'm going to get rid of this. 1 second. So we'll find out that hx is equal to minus 1/9 times that. And that is that question finished. So our last cubic question of our first revision week, show that x minus 2 is a factor of f of x. So if x minus 2 is a factor, so f minus 2 equals 0, then x is equal to a positive 2. To see if that is a root of my fx, everywhere I see x in my equation, I'm going to put in a 2. So I'm basically subbing this 2 in as a replacement for x in my function. So I'll get this minus 2 to be squared plus 2 times 2 minus 16. And hopefully that should all equal 0. If it does, then I know that it is in fact a root of 0. If I put that all in my calculator, that will equal 0, so therefore I know that it is a root. Or sorry, that x minus 2 is a factor and x equals 2 is a root. Given that fx is equal to this, find the values of b and c. So we know that fx is equal to 2x cubed minus x squared plus 2x minus 16. That's what we were told up here. And we know that if I multiply x minus 2 and 2x squared plus bx plus c, I will get that. So both those sides do in fact equal each other. But if you remember what we said before, we know the first thing times the first thing will get me the first thing. That's correct. We also know the last thing times by the last thing, sorry, not this one, the minus 2 times by c will get me 16. So if minus 2 times c equals minus 16, that means my c has to equal 8. So I can already fill in one thing. So now instead of 2 letters, I only have one that I don't know. Plus bx plus, I know that's 8 now. I'm going to multiply this out now. And I will get 2x cubed plus bx squared plus 8x minus 4x squared minus 2bx minus 16. And that is equal to this one here. I'm not bothered to write it again. I know that x squared on one side is going to equal x squared on the other side. Therefore, the thing in front of x squared on this side has to equal the thing in front of x squared on this side. So minus 1 is equal to b minus 4. Then that's an equation I can solve. I want to move this minus 4 to the other side, so I'm going to add 4. I'll find out that b is equal to 3. So now we've found that b is equal to 3, c is equal to 8. We have finished that question. The next question we're talking about is a modulus question. So we have 2 ways of doing modulus questions. We can square both sides, or we can do a very nice easy one. We can let the modulus equal the positive or the negative version of the other side. So this is the one I'm going to use in this case. So we're going to say that 5 plus 3m we know that equals 11. So therefore, what's inside the modulus, so 5 plus 3m, equals a positive 11. Or what's inside the modulus, 5 plus 3m, is going to equal a minus 11. And then I solve these two independently of each other. So minus 5 both sides, 3m will equal to 6, m is equal to 2. Minus 5 both sides, 3m is equal to minus 16, m is equal to minus 16 over 3. And this way is just a lot easier to do, because if we're going to square both sides, what's very, very important is we need to square this 5 plus 3m that is in the modulus. We can't not square that, because otherwise we will get the completely wrong answer. It is not okay to literally just square 11. We have to square both sides properly. Okay, so moving on. So this is a 2023 question. For the real numbers h, j, and k, express k in terms of h and j. That means I want k on its own equals whatever. That is the extent of what that means. So we're going to try and do that. 1 over h is equal to k over j plus k. First thing I want to get rid of, I don't like having fractions in there, so I'm going to get rid of those fractions. So I'm going to times both sides by h times, okay, so that'll get rid of my two fractions, and I'll get j plus k times by 1 is just j plus k on this side, is equal to k times by h. This is not good enough for me. In order to get k on its own is equal to something else, I need to get all my k's on one side. So that's what I'm going to do. I am going to move this k over to the other side. So j is equal to kh minus k. And now what I can do is I can take a k out as common. So j is equal to k times h minus 1, just using highest common factor. Then we're going to move up here because I've run out of space. So j is equal to k times by h minus 1. Since we're literally just times by that, I'm going to divide by that just as easily. So I found out that j divided by h minus 1 is equal to k. And that is my final answer. I have written k in terms of j and h. Okay, so this is 2021, paper 2, question 5, part B. So at 9 a.m. a delivery van leaves a factory and it travels towards its destination at an average speed of 60 kilometers per hour. It travels like that for 1 hour and 45 minutes before a second van leaves the factory on the same route, and that travels at 95 kilometers per hour. And they both reach their destination at the same time. How long does it take them? So we know that this car, or say this van, has been traveling by 1.75 hours. That is the same as 1 hour and 45 minutes. I've just converted those 45 minutes into a percentage of an hour. How we did that? We said 45 divided by 60, that is equal to 0.75. That's how I got my 1.75 there. So in that first hour and 45 minutes, it travelled 105 kilometers, right? So every hour, it's going to travel another 60 kilometers. So the first hour it leaves, I'm going to draw a little table here. So the first hour and 45 minutes, he left at 9, so now we're talking about 10:45. He's travelled 105 kilometers. My second van, which I'm going to call van B, he hasn't travelled any amount of kilometers. 1 hour later, this guy is going to have travelled another 60. So plus 60, he is going to have 165 kilometers under his belt. And this guy here for B, he's traveling an hour at 95 kilometers per hour, therefore he's traveled 95 kilometers. So they're not at the same place yet. That's no help to us. Another hour goes by. This guy is going to have gone another 60 kilometers. So he has gone 225 kilometers now. And this guy will have gone another 95. So he is currently at 190 kilometers. They're still not matching. We'll go another hour. So 1 hour later, we have 225 plus 60. He's traveled 285 kilometers. We have 190 plus 95, because again, he's traveling in an hour. He's going 95 kilometers in 1 hour. That's what his speed means. If we do that, he'll also get 285 kilometers. So now they've traveled the same amount of kilometers and the time is 13:45. So that means, therefore, they arrived at 13:45 at their destination.